let's solve some of the problem using Coulomb's law and superposition principle. So let us consider a configuration. We have a we have an equilateral triangle where the edges of this equilateral triangle we are keeping charges. Say we have 2q here. Let's call this point as A. So minus q at B and plus q at C. Okay, so considering this to be an equilateral triangle, so we know all the three angles of this triangle will be equal. So that is 60 degree each. So these all angle will be 60 degree each. So and all the three sides are also equal. Let us consider that all the three sides are A. So to solve this problem, so what we actually are going to find is what will be the total force experienced by minus q at B. Okay, so due to the other charges, due to plus 2q at A and plus q at C, because as you know, 2q is going to affect this charge and plus q is also going to affect this charge out here. So let's solve it. So solution. So first of all, we are going to write the magnitude of the force the minus q at B is going to experience due to the presence of plus 2q at A. Okay, so let's say let FB be, okay, so we are going to use term FA because the plus 2q is at A. So plus let FA be the force experienced by minus q due to plus 2q at A. Okay, so because of the plus 2q out here, so then we are saying Fa will be the force. So using Coulomb's law, we know we will just write the magnitude. So will be the k and will be the product of two charges. So which charges we are considering? We are considering one charge here. So we are considering this charge out here and another charge is here, and we are calculating the force in this charge because of this charge. Okay, so then it will be the product of two charges. So here you need to consider one thing: the negative sign is going to affect in the direction, but the magnitude is not going to be affected because of this negative charge. So while writing the magnitude of the force, here we will not consider negative sign. So the product of two charges, the one of the charge is q, the other charge is 2q, and the separation and the square of distance between them. So what is the distance? So distance is a out here, so it will be a squared. So then if I am going to solve this one, so a will be k 2 q times q will be a q squared followed by a squared. So give it as equation number 1. So now we have written the how much force in magnitude this minus q is going to experience due to the presence of this plus 2q. Okay, so right now we are not talking about in what direction they are going to experience a force, but we just are taking care of how much magnitude will be that force be. So again, so you know, since this minus q will not only be affected by the presence of this plus 2q at A, but it is also going to be affected by this plus q which is present at this point C. So now we will give that name a force, give that force a name, so that will be Fc. Okay, because the plus q is at C, so let Fc be the force experienced by minus q due to plus q at C. So again, let's write the magnitude. We know this Fc will be k product of two charges. What two charges we are talking about here? We are talking about this positive charge here and the negative charge out here. So it will be we don't use a negative sign out here. So it will be product of q and q and square of distance between them. That will be your a squared. This will be your equation number 2. Okay, so let not keep this equation number as 2. Let us solve this one and we'll see that FC will be Q and Q times Q will be your Q squared and A squared. So number 2. Okay. Now compare equation number 1 and 2. So comparing equation 1 and 2. So comparing equation 1 and 2, you see this FA. So FA, if I just bring 2 outside out here and bring this K, take this K inside, Q squared by A squared. So then you can compare K Q squared by A squared is nothing but FC. Okay, so you see, so this value out here is nothing but FC, because kq square by a square can be written as fc. So fa is simply nothing but 2 times of fc. If I multiply 2 in this fc equation, then I'm going to get fa equation. Okay, so now we have the relationship between these two forces. So that is fa is twice of fc. Okay, so then we can give this as equation number 3. Okay, so now we will take care of in what direction they will experience a force, and after that we'll try to solve it. So you know that uh, these charges out here, we know this the charges. We have an equilateral triangle, so we have a charge 2q here. This is I think minus q, and this will be a plus q. Yeah, so what name we have given? So we have given a, b and c. So this point out here is a, this is b, and this is c. Okay, so we are calculating the net force in minus q. So now we are not interested in how much minus q will exert a force on other charges, but only in how much minus q itself will experience. Okay, so let's look into the direction of both f a and fc. So the charge out here, so let me choose another color, so which will show you the direction. So the charge out here, charge plus 2q out here, is going to attract this minus q. So that means it is going to pull minus q towards itself along the line joining these two charges. The force is always along the line joining these two charges. So therefore, what we know is this minus q will be attracted by this plus 2q. So it will be directed towards plus 2q. So if I have to make direction, so that means the direction will be in this direction. Okay, so this direction. Okay, the force will be in this direction along the line joining the two charges. So this will be the force, and we have given this force name as fa. And now let's talk about how much force this plus q at C is going to experience, not the how much force this plus q at C is going to exert on this minus q. So again, you can see this plus q is also going to pull minus q towards plus q, minus q plus towards plus q. So again, if I have to make direction, so then the force will be directed in this towards C, because it is going to get pulled in this direction. Okay, so one, it is going to pull in up direction towards 2q, and another it is going to get pulled towards plus q. So then this force, by how much magnitude is going to get pulled, is fc. Okay, and then we also know the angle between these two fa and fb, since it's an equilateral triangle. We have already defined this angle, it is 60 degree. So we know the situation when a charge or a single particle experience two say two forces like this. So if it is a vector and b vector, so the resultant will be somewhere between a and b vector. So this resultant we can find using this vector law of parallelogram. In this case, it will be your a squared plus b squared plus 2 ab cos theta, and theta will be the angle between the a vector and b vector here. Okay, but in this case, instead of a vector and b vector, we have fa and fc. So therefore, the net force that is going to experience the net force experienced by minus q will be your f net, will simply be your okay, so we'll not write the vector equation, so we will just write the magnitude, because we already know the direction will be between, the resultant will be between fa and fc, so it will be directly somewhere out here. So okay, anyway, so f net we can obtain by taking the square root of fa squared plus fc squared plus 2fa fc cos of theta, where theta here is an angle between so fa vector and fc vector. So this in which means that theta is nothing but 60 degree out here. Okay, so we also know also know that what is Fa? Fa, so Fa is nothing but twice of Fc. So we can replace Fa by twice of Fc. Okay, so here we have already proven that this Fa is twice of Fc. So let's solve this equation then. So which implies that F net will be how much? So instead of Fa, I can write 2Fc. So 2Fc, which will be squared because of Fa is squared. So Fa squared means 2Fc squared plus Fc will keep it as it is plus 2. Fa can be written as 2Fc, and then Fc can be written as Fc only, and the cos in this case will be 60 degree. So cos 60 is nothing but half. Okay, and then let's further solve this one. It will be squared. What is 2Fc squared means 4Fc squared. 2Fc whole squared means 4Fc squared. With 2 times 2 is 4. Fc times Fc squared. Here we have Fc squared only. We have 2 times 2 will be 4, and Fc times Fc will be Fc squared. And here we have cos 60, which is equals to half. So we can cancel this 2 with this 4. We will get 2 out here. So what do we have here? F net. So F net will be 4 Fc squared plus Fc squared plus Fc squared. And then F net here will be, okay, so this will be 2Fc squared because 2 and 4 get cancelled. So 2 is here. So 4 plus 2 is 6 plus 1 is 7. So it will be root over 7 Fc squared. So then we have F net. So this is squared and this under root to get cancelled out for this Fc, and only under root 7 will be there, and Fc will come out from this square root because this square will get cancelled out with this under root. Okay, so again Fc equation we already know, this is k q squared by a squared, if I am not wrong, from I guess is equation number 2. Okay, so here you can see, yes, Fc is equation number 2, k q squared by a squared. So if I put the value of Fc in this net force equation, so then what I'm going to get, this will be root over 7. So k q squared by a squared. So this will be the final answer for the net force. That minus q at, I think, B is going to experience. Okay, so similarly you can also find how much force plus 2q will be experiencing because of presence of these other two charges, as well as you can also find how much force this plus 2q plus q at C will experience because of other these two charges.